The first three, 4, 5, it's just identify whether it's positive correlation, negative correlation, or no correlation. So that's just based off the slope of the line of best fit. 7, 8, 9 is you're approximating what the correlation coefficient should be, right? So that's almost where we're starting. So number 4, right? Just take a look at number 4. So you guys need to have your books open. So is the line, like if you were to hold your pencil on it, forming the line of best fit, right? Would the slope of the line be positive? Would it be negative? Or would it be no correlation? Positive? Okay. Then it's positive correlation. Yep. So that's all you got to do. All right? Everybody all right with that? Yeah? Okay, 8. There you go. Yep. All right. So for number 8, they want you to identify which of the 5 possible R values is appropriate for the graph. So the 5 that they give you to look at are -1, -0.5, 0, 0.5, and 1. So does anybody remember from yesterday, what does the correlation coefficient actually stand for? Yes, that's what the correlation coefficient tells you, okay? It tells you how accurate your prediction is. So the closer the correlation coefficient is to 1, the closer the dots are to your line of best fit. All right? The further the correlation coefficient is from 1, so that means that the closer that R will, let me try that one again. The closer R is to 0, that means that the further away from the line the dots are. Okay? Everybody okay with that? Yes, no, maybe? And as far as the positive negative is whether the slope of the line of best fit is positive or negative. Okay? So if it's a positive correlation, we'll use the positive values, right? This is like a positive perfect correlation. This is a positive strong correlation. This is no correlation. All right, this is a negative perfect correlation, a negative strong correlation, no correlation. Everybody all right? So for number 8, the first thing that you got to do is figure out if it's positive correlation, negative correlation, or no correlation. So take a look at number 8. Are the dots going up, going down, or are they all over the place? For 8?
I think it's all.
So as you move from left to right, like, again, if you're not sure, use your pencil. Okay, if you were to draw your line of best fit, right, is your pencil pointing up or is it pointing down? It's pointing up, right? So for that one, is that a positive or a negative correlation? Positive. So that means that it's not this, and it's not this. So the next thing that you have to ask yourself is if you were to draw a line of best fit, are those dots really close to the line or are they really far away from the line? For 8? Right, it's close, but it's not forming a perfect line, right? So I would call it 0.5. Okay, because a correlation of 1 means, like, if you look at number 9, right? You see how close those dots are to a single line? That would be a 1. Okay, actually that'll be a -1 because it's decreasing. But everybody okay with what I'm talking about? So I'm assuming you're talking for everybody else because everybody else is just sitting there. So number 12, they want you to do these as basically 4 parts, okay? First thing that you're going to do is take the data and make a scatter plot. The second thing you're going to do is you're going to draw a line of best fit. The third thing you're going to do is find the equation to the line of best fit or to the prediction line. And then the fourth thing you're going to do is use that equation in order to actually make a prediction of an unknown. All right? So up first for number 12, I need the data. So how many pieces of data do they give you here? 4 or 5? 5? Okay. Then I'm a little too long there. Okay, so what is my first data point? 12 and 100? Okay, next data point? Next. 36, 52. 64 and 9. Okay. So before we start going here, we need to kind of figure out some basics, right? So look at your X values. All right. Is the smallest X value really far away from 0? No, it's at 12, right? So do you think I need a break on my X-axis? No. What about my Y? Is the smallest Y close to the 0? Yeah, it's 9. Yeah, so am I going to need a break? Yeah, am I going to need a break on my Y-axis? No, so remember, when it comes to using breaks, you can use them, but you don't always use them, okay? Everybody all right with that, right? You guys remember the break from yesterday? It was where we put the little EKG mark, right? And that allows us to start the graph wherever we want. Okay. So now I need to get set up here. What quadrant are we going to be in? First one, because x is positive and y is positive, right? All right. Did they give us any labels for the x and y? No, they're just x and y, so I don't have to worry about labeling. For my x, what do you think I should count by? I have to go from 12 to 64. So what do you think I should count by? Huh? Tens would probably work. I think I can do this. Let me see if I have it. Yeah, I have enough room, I think, to count by fives. Yes, I do. Trickster for kids? No. All right, so 5, 10, 15. All right, so again, do I have to label everything? No, I just need to give enough so I can show my reader what my scale is. So what should I count by on the y's? 10? Whoa, that's a 3. Okay, again, do I have to really label each one? No, you just have to show enough for the reader to be able to follow, right? Why do you think I went through the time to do that? Because I don't like counting every time, like 30, 40, 50, you know what I mean? It's all right there, so it's faster for me to track. Everybody good? All right, so where's my first dot? Okay, so I go to 12 on the x, that's a really big dot, which is about here, and then up to 100. So somewhere like that. All right, and then 25, 75, right? 15, whoops. 15, 20, 25. 75 is going to be there. 36, 52, 15, 20, 25, 30, 35, 36, 52. 50, 26, 30, 35, 40, 45, 50. 26 is going to be there. And 50. Wait, did I miscount one? 20, 30, 40, 50. Yep, I'm off by an axis. Hang on. 50. 50, 65. 64, 9. All right, so there you go, right? Everybody good with making your scatter plot? All right, so line of best fit, right? Again, am I going to have my line pass through every single point? No, what I want to get is what? Okay, I want 2 points, and I want to be as close to every point as I can, right? All right, so for me, I'm thinking that point there. So I'm thinking something like that, right? So I'm using this point, and I'm using this point, right? So that is point number 2 and point 5. Everybody okay with that? Yes? No? Maybe? All right. So now that I have my line of best fit and I have the 2 points that made that line, I'm going to come over here and find the equation. So I need 25, 75. And what was that? 64, 9? Okay, so if I give you 2 points, how do I find the equation of the line? What's the first thing I need to find? It's slope, so I'm going to use slope formula. So m equals 9 minus 75 all over 64 minus 25, which gets me negative 64 over 44, 39. Can 64 over 39 get smaller? No. Nope. That's it. Huh? This is the same problem. That was step 1. This is step 2. Actually, that was 1 and 2. This is 3 and 4. Yeah, each of these problems are 4 parts. Which is what I said at the beginning. So now that I found my line of best fit, I have to actually calculate the line of best fit, the equation to it, which is what I'm doing right now, and then I'm going to use it to predict an unknown. All right? So here's my m. It can't reduce, so I'm going to plug it into point slope form. So y minus 75 equals m times x minus x1. Everybody good with that? Yeah? I know a lot of people see the big fraction. Ooh! That's why they invented the calculator. So now we're going to distribute here. Get negative 64x over 39 plus 64 times 25 divided by 39 equals that. Oh, all right. I'm taking this and I'm distributing it in. So negative 64 over 39 times x is negative 64x over 39. Negative 64 over 39 times negative 25 is 41.025641. Okay? Yeah, the 4 decimal places, though. So you're going to put down for your answer 41.0256. Everybody all right with that? Yeah? All right, so now how do I get y by itself? Add 75. Well, they're big numbers. Yeah, you're going to run into that. Like, you guys have to remember, when you do work in a math textbook, right, somebody wrote that. So it's not just random numbers. They're usually trying to remove fractions so that way you can understand the underlying principle. This is more real life, okay? And you're going to get just sometimes some nasty numbers, but you just write it down and keep moving with it, okay? Try to not let the fact that it's a disgusting-looking fraction, like I got somebody in third hour who's like, that fraction just looks wrong. It's right. Just trust what you're doing is right. Trust the process, and whatever the number is what the number is. Okay, don't get too wrapped up in what number's spitting out. Everybody okay with that? Yeah? All right, so here's your equation. So this is part 3 done. Part 4 is they say they want you to predict the y value when x equals 20, right? So I'm going to take this equation, and I'm going to plug in 20 for x. All right, so just plug that into a calculator. We're going to take negative 64 times 20. We get that. We're going to divide it by 39, and we're going to add 116.0256, and we get 83.2051. And if you look up the answer in the back of the book, it says about 83. So if you chose to use different points, you might get a different answer, right? But I want you close to that. So if the book says 83 or about 83, that means if you're between like 80 and like 88, somewhere in that range, you're good. Everybody all right? So regardless of which points you're using to form your line of best fit, you shouldn't get anything really far distance away from the answer in the back of the book. All right, but you might not get exact answers. Is everybody all right with that connection, yes, no? So don't worry about getting exactly what it says in the back of the book. Just be close to the back of the book. Yes, sir? It says in the book, if you had it open, that once you find the line of best fit, they want you to use it to predict y when x equals 20. Yes. 12. All of this is 12. 2 slides. So, yes. So you make a scatter plot. You draw a line of best fit on the scatter plot. You have to make sure that your line of best fit passes through at least 2 of your points. You mark what those 2 points are, and you mark them over here, okay? So that way you know which pieces transfer. So I'm going to use 64 and 9, and I'm going to use 25 and 75. Is everybody all right with that? Okay, come over here with my 2 points. So I'm just using my 2 points. When I give you 2 points and I say find the equation of the line that passes through those 2 points, you're going to calculate slope. So you use y2 minus y1 over x2 minus x1, find your slope. You take the slope and one of the points that you have and use point slope form, which is what I'm doing here. It's just like what we did 2 sections ago. Alright? And you guys are like, oh, this is starting to get easy. This is where we use it. Alright? So calculate your slope, pick your slope in one of the points, plug it into point slope form, solve for y just like we always do. Distribute the slope with x, slope with the x of 1, and whatever you get is what you get. Alright? To get y by itself, I have to add 75, so add 75. Now that I have my equation in its disgusting self, we plug in 20 for x, use our calculator because it's our best buddy, and get a single number. That's it. Everybody all right? So what's hard about this should be the numbers look really gross, but the actual process shouldn't be that hard. It's just using stuff that we've already covered. Okay? Any major questions? All right, number 14. Same kind of thing, right? So what is the data for number 14? Okay. So this time around, same basic approach, right? Here's my data. The first thing I need to do is figure out when I make my scatter plots if I'm going to be taking advantage of any breaks, right? So take a look at my x values. Are those x values really far away from 0 or close to 0? Close. So do I need a break? Okay, take a look at your y's. What's the smallest y value? 120. Is that really close to the 0 or far away? Far away. So I'm going to use a break on my y-axis. So for your x-axis, you said it. We just have our x-axis. All right, for the y-axis, hey, get back here. There we go. We're going to start off with a break. And go up from there. Arrowhead, 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 arrowhead. Everybody good? Yep. All right, so what's my smallest x value? Or sorry, yeah, what's my smallest x value? 5.6 is my biggest? 8.4. So, I could count by 0.5s in here and it would make the graph look really pretty. So that's what I think I'm going to do. Counting by 0.5s. Okay, there we go. Everybody all right with that? Yes, no, maybe. All right, now what's my smallest y value? 120, and what's my biggest? 167, so I don't have a huge amount of space to travel, so I'm going to count by 5s on this. But I'm going to start at 120. And then 125, 130, 135, 140, 145, 150, 55, 60, 65, 70. Whoa, what am I doing? Alright, that should be a 150, 145, 140, 135. Everybody alright with setting up your scales and everything? Yes? If the smallest value on that axis is a really far distance away from 0, you use a break. The smallest x is 5.6, that's close to 0, so we don't need a break. For y, the smallest y value is 120. That's a far distance away from 0, so I use a break.
Okay, so it's just the one.
On this one, yeah. So this one we only need a y break. We don't need an x break. All right, so again, plot all your points, right? 5.6, 5.5, 5.6, and 120. It's going to be like that. 6.2 and 130. 7, 141, 7.3, 156, 8.4, 167, like that. So real quick, is this a positive or a negative correlation? Positive. Okay, so that means that the slope of my line should be a positive. So I'm going to say that's my line of best fit, and I am passing through this point and this point, which is 0.2, 0.5. Everybody okay up to this point? Any questions on how to make a scatter plot? Any questions how to find your line of best fit? Or any questions how to identify the 2 points that your line of best fit is passing through? Yes, sir. Huh? Yeah. So you need a ruler, and you want to make sure that you're passing through two of them. Okay. So it'll be really close, right? All of the points will be really close to the line, just like mine are, right? Everybody okay? Yes or no? Any questions? All right. So for the 2 points that I'm using here, I've got 6.2 and 130. 6.2, 130, and 8.4, right? Yeah, 8.4 and 167. Okay. So if I give you 2 points, how do you find slope? Okay, so first things first, right? Slope equation, which says what? Okay, 167 minus 130 is 37, right? 8.4 minus 6.2 is 2.2. Yeah. And even though technically it's not proper to have a decimal in a fraction, I'm not going to make you convert it over and all that garbage. Okay? So if you want to, you can leave it like that, or you can type it into a calculator and get a single decimal. It's up to you. Just remember, the more decimals we use, the less accurate your numbers are. Okay? So now we plug into the formula, right? Y minus 130 equals 37 over 2.2 times x minus 6.2. We distribute on the right-hand side, get 37x over 2.2 minus, bust out your calculator, right? Clear off all the old stuff. 37 over 2.2 equals that. Times it by 6.2 negative, right? And you get negative 104.2727. Any questions on how I got any of that? Okay, so how do I get y by itself? What do I do?
Add 30.
Add what?
30.
Not 30. 130. There you go. So y equals 37x over 2.2 plus, let's try this one more time, 130 minus 104.2727. There we go. That looks a lot better. 25.7273. So this is what I'm saying the line of best fit should look like. That equation. Everybody all right up to this point? Yes or no? I just added the 130. So I took negative 104.2727 plus 130. Okay, in order to get y by itself, and that's how I got the 25.7273. Okay, again, what's the value they want you to predict? Okay, y, 1x equals what? Okay, so take your x, replace it with a 20. So you get 362.0909. So anything around that, basically between 355 and around 370. Okay? You should be good. So again, don't worry about getting exactly what the book says. Just make sure you're close, within probably 5 to 10 units in either direction. All right? Is there anything else on your homework that you still want to see, need to see? Want me to re-explain? Want me to go back through? Yes, no, maybe?